So we're going to do the last form of quadratics, of graphing quadratics, of what you're going to see it in. We already did factor form and standard form. We did unit on factor, unit on standard, and now we are going to look at vertex form. So your objectives is that you can identify the parts of the vertex form, you can graph from vertex form, and you can write an equation of a parabola in vertex form. Alright, so this is vertex form, and we did a little activity with Sketchpad you were supposed to do with your last one to understand a little bit more about vertex form and what each one of these variables do, a, h, and k. You found from the activity that the vertex is always, let's change my colors, h and k. And remember, h is a little tricky. It is the opposite. K is not, just the h. Also, on the little side note, we learned that h moves the parabola left and right, and k moves the parabola up and down. Alright, so from here we can find our axis of symmetry, and remember the vertex. Think of our parabolas that we've been doing for the past few units. Is always on the axis of symmetry. So since this is my vertex, it's the x-coordinate of the vertex, so it's x equals h, or h, remember, is opposite. So this was 1 in here, so it's plus 1, this would be negative 1. So it's negative 1, then this would be 1. The role of a is the same. It has not changed. This a is the same in all three forms. That's how important a is, that it shows up in all three forms and does the same thing. It makes it open up, down, remember it's positive or negative, or it's going to be narrow, or grows fast, or wide, which means it grows slow, and that's when it's close to 0, far from 0, and it's narrow. Alright, so let's just write the equation of the parabola with a given vertex and a value. So remember, our vertex form is y equals a, x minus h, squared, don't forget that squared, plus k. Alright, so our a, so we know it's always going to be y equals, a in this case is 5, then x minus h, this is your h, and k, since my h is negative 1, it's the opposite, so it's x plus 1. Just kind of like when we were doing a factor form, it was always the opposite side. And then don't forget your squared plus 4. So b, y equals, a is 1, so we actually don't need it. And if you don't see anything out here, that means a is 1. X, my h is 2, so we do the opposite, which is negative 2, squared minus 3. Here we have y equals, a is 1/3, x minus 0 squared plus 8. Now, if you think about it, x minus 0, if you think anything minus 0 is what you were subtracting, so if this was 4, 4 minus 0 is 4. So this is just x squared 1/3 plus 8, or you don't even need the parentheses, it's 1/3 x squared plus 8. Alright. And then on your last example, we have negative 1, so y equals negative 1, x opposite of 7, your h, and k is positive 7 squared plus 0. A couple things you can simplify here. We have a negative 1, so we can just have a negative up front, which is what you would see. X plus 7 squared, we can't simplify, and then we don't need the plus 0. Alright, so we're going to do a couple graphings from vertex form. So looking here, we have your a, your h, and your k. So graphing, a is positive, so it opens up, and we know it's 2, so it's going to be a little narrow. Our vertex is our h and k. H is opposite, so it's minus 1, so it's 1. K is 3. We know at 1, 3 is going to be a vertex, so our graph is going to go this way. Axis of symmetry is x equals 1. To To get the y-intercept, remember the y-intercept is on when x equals 0. So I'm going to plug in 0 into my equation. So y equals 2. 0 minus 1 squared plus 3. 2, again, take it in steps, don't rush it. Negative 1 squared is 1, so it's 2 times 1 plus 3, which gives you 5. And I just realized I plotted this point wrong over here. I did 2, 3, not 1, 3. So you got 1, 3, 2, 5. Alright. So we have 0, 5. 1, 3 is our vertex, and then we have a value of 2. So I just need one more value. I'm going to do 3. Or you could do negative 1, just kind of with the next x value you haven't did over. So 2, 3 minus 1 squared plus 3. So 2 squared is 4. Or that's 2 squared plus 3. Again, take in steps. So it's 2 times 4 plus 3, which is 11. I'm just going to go 1 off. If you're just 1 off, don't feel like you need to change your scale. If it would have been anything bigger, I would recommend you erasing these points and redoing them. So there is your parabola. Right, so on F, so we have your A, your H, and your K. So your A is out front, it's negative. This is at negative 1, so that's going to open down. Your vertex, opposite of H, so negative 5, 2. Right there. Axis of symmetry is x equals negative 5. It's the x-coordinate of the vertex. Y-intercept is going to be at 0. So we're going to plug in 0. So we have negative 0 plus 5 squared plus 2. 0 plus 5 squared is 5. 5 squared is negative 25. Plus 2 is negative 23. I'm probably not going to graph this as included as my 5 points that I need. Again, you only need 5. We don't have to do 7 anymore. Just because it's way off, and I could probably find some points a little closer to my vertex right here. Which is what I'm going to do. So I have negative 5, 2. I'm going to do negative 4, the next x value over, or you could have did negative 6. So negative 4 plus 5 squared plus 2. So it's negative 4 plus 5 is 1. 1 squared plus 2. That's 1 squared, that's negative 1 plus 2 gives me 1. Which would make sense, those points will be there for it to open down. Negative 3. So negative 3 plus 5 squared plus 2. Negative 3 plus 5 is 2. 2 squared is 4. It's negative 4 plus 2. Again, follow your order operations. Gives me negative 2. Yeah. So again, if I just pick 2 other points and not use my y-intercept, I didn't need to change my scale because they were closer. You don't want to get too far away, which my y-intercept was. Alright, so now we're going to reverse it. I'm going to actually give you the equation, and then you'll find vertex form. You have to kind of think back to when we did factor form. Okay, because we're going to have to solve for A, and it's the same kind of procedure that we did before. So you should see some parallels with it. So up here, notice I give you some starting points. You need a vertex because we're trying to find this equation. And the 3 things we need is the A, the H, and the K. Well, the H and K is just your vertex. So that point right there, which is at negative 3, negative 5. So I know it's A, it's opposite, so it's x plus 3 squared minus 5. I need to solve for A. So the way we get A is that we can fill in for x and y by getting any other point besides the vertex. So I'm kind of looking along. I have a nice point here and a nice point here. I'm going to use this one, -1, 3. You could use -5, 3. That works. Or you could use a point right here. You could use -2, -3, -4, -3. Any of those 4 points would work. You cannot use the vertex or you're going to end up with a being 0, which isn't correct. All right, so I'm going to use -1, 3. So instead of y, remember this is x, y, we're going to have 3 equals a, -1 plus 3 squared minus 5. 3 equals order operations, parentheses first, so that's 2 squared minus 5. 2 squared is 4, so I have 4a minus 5 equals 3. And add 5. 8 equals 4a. Divide by 4. A equals 2. Which 2 makes sense because my parabola opens up and it's a little skinny. So my final answer is 2x plus 3 squared minus 5. Okay, so last example. So you have your vertex we need, which is 2, 4. Again, we're putting it in this form. So we have our h and k, 2, 4, so I know it's a, y equals a, opposite h is 2, opposite is -2 squared, plus 4, k stays the same. And one other point, I'm going to use this point right here, or you could use 0, 0, 4, 0, or 3, 3, doesn't matter. I'm just going to use 1, 3. 0, 0 might have been pretty easy too. So plugging in, remember this is x and y, replace x and y with y is 3, a, 1 minus 2 squared plus 4, 3 equals a, 1 minus 2 is -1 squared plus 4, -1 squared is 1, so it's 1a, which is just a, plus 4 equals 3. If you have the 1 there, it won't matter. Minus 4, 1a is a, so equals -1, which -1 makes sense because my parabola is opening down. So y equals -1, remember you can just have negative x minus 2 squared plus 4. Okay, so that concludes this video. A lot of different things you do in vertex form. Kind of same procedure we're graphing and then writing the equation. Remember, this is very, very key in the part that most students forget, that a is the opposite for the vertex. If your equation is x plus 3, then your vertex is -3. If I give you the vertex -3, you gotta go plus. Remember, the role of a is the same in all 3 forms. It opens up and down, makes a narrow y. And again, when you're solving, does a make sense? If it's positive, does your parabola open up? If it's negative, does your parabola open down? Just a reminder to do reflection so you get credit for watching this video.